Okay, so let's say we have a wire with the current going down, oh my god, down like this, and we've got another wire which is in pen, it's parallel to that other wire, and it's going down as well, so the current is down, right? Like that. Okay, so let's think about what magnetic field this first wire is going to have. So we use the right hand rule. Okay, so it's curling around like this. So it's like this. So it's going to be going into the page here, out of the page here, and of course this field is actually going to be very it's going to spread out to here as well. So you know, we have it everywhere, except it gets weaker as you go out, right? Okay, now what about this one? Well, the current's going down. Use the right hand rule, so it's going to be like that. And likewise, it's going to extend out, right? So you've got that. Now we have to use Fleming's left hand rule. But I like to do it better. I prefer to do it with this set square rather than using my hand, because hand is quite inconvenient, you know. I'm not that flexible. So what I do is I look at which way up the writing is. That's going to be force, right? Like this. So force is upwards and the writing is facing upwards, so force is up like this, right? And so similarly, this long edge is going to be the field. This short edge is going to be the current. So it's just the same thing as the Fleming's left hand rule, except it's easier to manipulate for me. So if you look at the effect of the second wire on the first wire, we can see it's this. The black is the second wire, so the field is going in to the paper like that, right? So the long edge is going into the paper, and the current is downwards, like so. Now if we take a look at the set square, where the writing is the correct way is towards the right, like that. So the force on the first wire due to the second wire is going to be this direction, and likewise we do the same thing for the second wire. We look at the force on the second wire due to the first wire, and it's the same thing except the magnetic field is coming out. So if we get our set square again, the magnetic field is coming out, the current is downwards like that, so we basically have the force going that direction, okay? And so you can see that they're going to attract. Attract. Okay, let's try again, but the currents are moving in different directions now. See what happens. Okay, so this one's going downwards, so we have a right hand rule like this. So it's going into the page on this side. Oh yeah, into the page, I just got the... Yeah, so it's going into the page and all the way over to here as well. Okay, into the page. Oh, and obviously on this side it's going out the page, right? Okay, now, so that's I2. And that's the effect of I2 on I1, right? Now, let's do the field due to I1. So we're using the right-hand rule, and it's coming like this. So, it's going out of the page over here. It's going into the page right here. And likewise, we have this sort of situation. So let's consider the effect of I2 on I1. So we're going to use the square thing. So the field is going into the page, the current is going up, so we're going to have a force like that, right? That's the force due to I2 on I1. Okay, now let's see the force due to I1 on I2. So we have that, right? So the field is going into the page, the current is going down, so it's basically and the writing is facing that direction. So it's basically like this. And so you get something like this, which is repel.